There's a red light on the back.
Yeah, it's all right now. It's a little bit. All right, so I had some students ask about videos. I tend to have like backups or backups. So if you go into use your video, you will find here are going to be your lectures. This is from Monday, so I got to buy. I'll flip those around. The date is where you can find. Try and keep that file system simple. So I'll be uploading those. That's one place you can find that media. And then you can also go to course materials content. And there's a link to the YouTube videos, and this is a playlist that has all of the videos. So like I'll upload them to YouTube as well. Not only just because some people like watching YouTube, and if you're watching a YouTube video of, I don't know, dirt bikes or something, hey, guess what? You can also go watch your soils class. So sometimes that works for students. I can keep all the lectures right there in one playlist. They're all in order. You can go back and look at whichever one you think you might need, and they're all there. So there's going to be 2 different places that you can find those videos. All right. I also uploaded that fertilizer document that we did in class, and then I also uploaded the key as well, right? That's more so just that you can practice with that. There's no assignment for it, but like it's going to be on your calculation 1. It'll be due in a couple of weeks. I think in like 2 weeks or so, that calculation 1. So I'll get that document straightened out. So you will be responsible for that, and you'll just turn it in with calculation 1. The crossword is due tonight by 9. There's only a few people who haven't done it. I apologize if there was any kind of like, wait a minute, this wasn't nearly as simple and easy and straightforward as I thought it was going to be. I got that from a different professor and thought it might just be a good way to introduce you to soils by reading chapter 1, but you didn't have to buy the book to do that. So, yes, sir.
It says on the assignment 1, there's like a Dropbox where you put in something to turn it in. I don't know what to turn in on that.
You don't turn anything in.
Okay.
You just, the only thing you have to do is answer the quiz.
I was just making sure it wasn't.
If you turn it in, it's okay. I'm not gonna.
The only thing I submitted was the answers.
The quiz?
Yeah.
On the quiz, that's all you had to do.
Okay.
Yeah, it was just the quiz. Again, that was something that professor did, and I like it because I don't have to go back and grade 26 crossword puzzles, right? So, I've got 50 students that I have to grade for just in this class alone. So, doing that through iLearn and taking advantage of that, I can grade those quizzes quickly. You get your grade back quickly, and we can kind of move on for that. If you turned it in, okay. If not, you didn't. I'll typically put some instruction in here about what you should or shouldn't do, and it's pretty straightforward. You're either going to hand this back in or you're going to take a quiz online of some sort. Okay. Any other questions regarding assignments or quizzes, labs? Everyone barely tracking? Alright, so we left off kind of right here. This is where we left off. So we also talked about what are the 5 soil forming factors. I'm going to give you one. Parent material, climate. The organisms that are going to kind of travel through that soil. So we got parent material, climate, organisms. It takes a lot of time to form soil, and we got one more. Topography. I'll put it on this hand since I've split that up. So we got parent material, time, climate, topography, and the organisms. What about the soil forming processes? There were 4 of them. We have 4 soil forming processes. Additions. Losses. I feel like this is like a addition, subtraction, multiplication, and division, which kind of it is really now that I think about it. So we have additions and losses.
Translocation.
We got translocation and transformation. Additions and losses, translocation. Put this in there twice. And so this, I found this graphic that kind of shows you that we're going to have some leaf litter fall, a tree, a plant. Something is going to fall on top of this that has some organic material that is going to decompose over time. Some things might be lost. Those nutrients that are contained within that plant material or that organism are going to translocate or infiltrate into the soil, and we'll have some transformations or some losses out the bottom, just to kind of give you an idea of like how this thing looks. So we got these layers that are forming, this leaf and plant material, and so some transformations are occurring throughout this entire process. So next we're going to get into the soil classification. Y'all, this is going to be glory. I'm like, this is my least favorite part of soils. Okay, I am not I'm not the pedologist. I'm more of the edaphologist, right? The pedologist does what? In the notes. What does the edaphologist kind of study? What's that?
I don't know.
You don't know? It was like one of the first things that we did.
Okay.
Ediphology kind of relates to the rest of life.
The ediphology relates to the rest of life, right? So the soil influence on living things. And pedology is understanding about the morphology of the soil and how it formed and why it formed. Those are not fun hype. I mean, unless you're into that kind of thing. Do we have anybody in environmental agri-sciences? We don't have a lot of people that are trying to go work for NRCS, right? So the NRCS that have a soil scientist, they're really into like how the soil formed, and all of. I'm trying to grow food because we got 9 billion people that we gotta feed, and I'm trying to make a little bit of money at that as well, right? That's kind of my man right there said, yep, that's what we're trying to do, right? We're trying to grow crops and make a little bit of money at it so that we can live a comfortable life. Soil is old and it takes a lot of time for it to change. So those positions are held by people who like their government NRCS job, in GS 11 or 12 or whatever, and they're going on to get a government retirement. They stay there and talk about. But I can't teach soils without talking about the soil orders. It's just, I can't. It's like taking animal science and not talking about sheep or goats or any pigs, swine. Like, we gotta cover everything, okay? So we're gonna go through this, we're gonna grit and bear it, just to say that you were introduced to this in soils, because I don't need you coming out and someone going, you took soils and you don't know what an alpha sol is? You may never get that question, but still, I can't have that on my academic record. All right, so a long time ago, back when they didn't have anything to do in the 1870s, and they were just walking around wondering what was up with this soil. And then here in the 1920s, they started understanding, so somewhere between 1870s and the 1920s is kind of when our land grant institutions were formed. And during that time, the way that they were doing agriculture is they would farm the land for, I don't know, 5 years maybe is probably about what it was, and then they'd leave it, and then they'd go off somewhere else, and then they'd ruin that land, deplete it of all its nutrients, and move on. So someone said, hey, you know what? We need to make sure that we're a little bit more sustainable so that we can farm this one piece of land for generations. So in order to figure out where the best soils were, C.F. Marbutt decided that he was going to go across the country like Lewis and Clark and start identifying and classifying these soils so that he could say, hey, if you go over to Arkansas, this is kind of what you can expect. You're in Ohio, this is what you can expect. Like, they didn't have anything else to do, so. We had this pedon, so the pedologist, they studied the pedon, which is this smallest sampling unit that has the full range of properties and characteristics of that soil. So if you can think about a soil sample, how many of y'all ever pulled soil samples with the probe? So if you can think of that, but that goes like 3 feet deep until the bedrock. So all the way down until that one big soil up, that is a single pedon. So that kind of holds everything from the top to the bottom. Those polypedons are the group of similar pedons. So if you pull one soil core here, and then you kind of step over here and pull another soil core, and they're similar, that's part of the polypedon. But at some point in time, the soil changes. So what they were doing is they were going across, taking those pedons. Oh, this one looks different. They draw that boundary. And so this is kind of where we got our soil survey from. And beginning in like the beginning of module 2, we'll go into the lab and we'll do web soil survey like Ms. Hannah did from, you remember doing web soil survey? I've actually had students use that. They're like, you know what, this is where we need to use web soil survey. So if you get a new piece of land, go to web soil survey and you can find out some information about that before you ever even show up on site. And so we call those soil series, which is a class of soils. We might have like a Baxter Churty silt loam or a Mount View silt loam. So they kind of label it similar to a city or some area. So here we have our land areas, might be on your farm. You see these polypedons, they're a little bit larger because they're trying to show that in the picture, but this is the same thing as me taking that one soil core. So a pedon into polypedons, those soil individuals that are similar, they would be classified the same as a, let's say it's a Baxter Churty silt loam. I'm gonna do this slow because there's a lot of information up there. Right, so we have these different diagnostic surface horizons. We have a molic epipedon, and so these are kind of based on our soil orders. You'll have to write this in, or did I already? Oh, okay, good. I thought I added the other one. So the difference between a molic epipedon and an umbric epipedon is really the base saturation. Is there a lot of calcium, sodium, potassium, magnesium? Then we'll have an ochric and a melanic. And when I think of ochric, I'm thinking low organic matter. Ochric, low organic matter. Melanic is going to come from a volcanic soil. You'll probably find this up in like Washington, obviously where there's going to be volcanoes. We have a histic epipedon, so we have a lot of organic material, peat and organic matter. And then this one's kind of a new thing that's coming on, and we have this anthropic or plagic. And when we think of anthropic, anybody heard of anthropogenic activities? Which means what? Anthropology, humans. So this has some human influence. We have now done something to this horizon, and we can tell that that is from some human activity. Something like mine spoil. They'll come in, so the mining operation will come in and they'll remove all the soil above the coal. They'll mine that coal, and then they have to come back in and replace it as if it was never touched. That would be something that's like an anthropic horizon. So something that happened because of humans. Next we have argillic and natric. So in argillic, you're going to see a lot of silicate clays translocated from the upper horizon. So this is where that soil forming process is, and that clay is so fine and soluble that it moves through the pores in the soil and moves down to a different horizon. Natric, sodium. So clear indication, you have 15% more exchangeable sodium, you'll have a natric horizon. You'll typically see this in arid region, Phoenix. You'll see this in Arizona, New Mexico, Colorado, places that don't have a lot of, California, Nevada, they don't have a lot of rainfall. So that salt actually stays in like those upper horizons. We have candic and oxic. Oxic being highly weathered, less than 10% minerals. It's mostly just aluminum and iron. We'll go over this kind of when we go about soil colloids. This will come back. And then spodec, kind of our forest soils. Not a lot of changes happen there. Good. All right. So these are, you'll definitely see most of these kind of in your more arid regions. Again, because we have rainfall that's carrying those salts or irrigation water, and that water is evaporating and leaving back the minerals. And you have this over time, but like the water never makes it all the way down to the ground, to the water table, so the nutrients and the calcium or the gypsum or the salts like the sodium, they never really make it all the way down. So they really just kind of collect in a certain area in that horizon. And when we see those things, if you ever get to a soil pit, when we see those things, like we're able to kind of look at that and go, here's a problem that we might be having, because deep down you're really having salt accumulation, and if the water table ever does rise back up, that's going to influence your crops. And then we'll have these pans that we typically get from our actual agricultural production. So you get this pan layer, and then you have to come in and plow that because the roots can't make it through. So then within the way that we name our soils and the way that we classify them, this is where the climate comes into play, and we can classify our soils based on the climate. We have aquic, which is going to make sense, right? That's under a high moisture regime, aquic. Low oxygen, so these are going to be like wetland soils. You'll see some glaying modeling because there's just no oxygen, so we have a redox reaction that changes the color of that soil. Eudic and eustick, and I kind of put these in order from saturated to least saturated, like aeritic being real dry, and then the Mediterranean climate. So eudic, eustick, aeritic, and xeric. Xeric kind of being in the middle. Trying to get all the boring stuff out of the way in the beginning of the semester so we can have fun for the rest of it and actually fly. Did everyone have that? Everyone good there on the different soil moisture regimes. Within our classification system, they're also gonna have temperature regimes, and temperature is going to influence our climate. Y'all remember what the, when we talked about that biochemical reaction, if the temperature increases every 10 degrees Celsius, what happens to that rate, that biochemical reaction rate? It doubles. So those reactions, if we have a high temperature in thermic or hyperthermic, these soils are going to develop quicker because that biochemical reaction rate is twice as fast. So if we have a very cold climate, you'll find that those soils don't develop. There's just nothing living there. I don't like I don't like cold. If it's cold, I'm staying inside. I don't move very much. So those microorganisms don't inhabit that soil, and organisms are part of soil formation. So for all of those things and how they kind of go about laying those out, they fall in these orders, suborders, great group, subgroup, family, and series. This is kind of like how we do genus and species for plants and animals. Am I going to expect y'all to know how to get in and out of these? No. I want you to be able to name the 12 soil orders and understand a little bit about them, but for the most part, you don't care. That's not what we do. We're trying to grow food or animals, or try and preserve the environment in some way, shape, or form. But we have 12 soil orders, the suborders, come on now, and these great groups, and then these series. Like this is what you'll run into the most, is this soil series. What kind of soil is it? That's a Baxter Charty Silt Loam. And if you really need to know anything more about it, you can go find out. Just kind of some information in case if you ever have to do that for a client or a boss. So we have 12 soil orders. You'll need to know these. The question will be, list the 12 soil orders. Something I want y'all to, you remember when we had this problem with the way that I learn, want you to enter the answer the way that I put it in there? Don't put the S on the end of the soil order. It just got confusing, and I put it in as alpha salt, because when I talk about what's the soil order, it's an alpha salt. But within that soil order, there are a ton of suborders, and we call those alpha salts. It's an S. Please don't put the S on the end of the answer. If you do, it'll be okay. I'm not going to count it off. But if you don't want your test grade to be very low when you're done, don't put the S on there. Because I didn't put the S on there in the I learned answer. All right? And so within each one of these names, there is this little formative element, this kind of little key thing that I can look at when I see this big super long name of a soil, and I can go, that's an alpha salt, without ever even touching it. So this alpha comes from right there. Next, if I see something that says like a candy, I'm trying to think of something that would be an anisole. I guess it really doesn't matter, does it? But just that little A and D in there is going to give me an indication. I can look at that great group and say that's an andesol. And so these are going to be our volcanic soils. Iridosols formed from an arid environment. So very dry, arid region will have that low organic matter and sodium. The nitric horizon, Na, sodium. And that little formative element is ID. So at the end of it, it will say something like a Eutrodids. It might have an S on the end of it. Entosols. These are very newly formed soils. When I showed y'all the place right out there on right there at the intersection of I-40 and 111, that soil that is forming there, right there in that little crevice, is an enthosol. Nothing's happened much to it. It's brand new, there's no horizon development, very little profile development, but most of the nutrients are gonna be right there in the top 6 inches. So they are kind of productive. They can be. Next we have gelisols. And so this little EL is the indication that it's a gelisol. And this is going to be in our permafrost. So it's kind of like a gelatinous type of soil because nothing's really completed the process. It started in the summer, like let's say we're in Alaska. There is a period in Alaska where it's not completely frozen all the time. So during that time, life happens, those insects start to do their thing, but then like a few weeks later, it's right back to cold, or whatever it is, right? It might be a month or 2. So they never really got to complete that process, and you have all those exudates and kind of the stuff that's left over, that stuff from those organisms, and when it gets frozen and solid, it kind of forms a gel. Next, we have our histosols. Now you're going to find these mostly in Florida, where we have Florida, maybe South Louisiana, where we have where we get our peats from, our bogs, and they're going to have a high organic matter. So if you remember just a couple of slides ago, when we had a histic subhorizon, it was high organic matter. Our insectisols are the second youngest soils. If you remember the movie Inception, it's kind of the beginning. This is when the profiles are actually starting to develop. We're going to get some of those diagnostic horizons because those soil forming processes are starting to take place. Not the forming factors, the processes of those of the additions and losses, translocations and transformations. Next, we have our mollisols, which are going to be a higher base saturation than our alpha sols. And so you might find alpha sols kind of in the uplands, and you will find mollisols kind of in the lowlands, especially in the Great Plains area, because there's a lot of grassy material, and so those fires that are just part of the natural processes that happen in the wilderness, that organic matter gets turned over, so there's a lot of there are a lot of bases that are in that organic matter. So we get grass that grows, it dies. Those soils are very deep because that organic matter, that plant material, is dying every couple of years. The weather is such that, or the climate is such, that it decomposes quickly. I kind of have a problem with my yard that I mow the grass and the plant material doesn't decompose quick enough before I mow it on the next week. And so I'm mowing last week's grass this week. Well, that doesn't necessarily happen here. There we go. No, that's part of it. You didn't do anything. That environment in the Midwest, they get enough rain, they get enough movement, they get enough material, and those organisms, that habitat, that climate is ideal for a lot of microbial activity. So they have very deep soils because it's layering on top of itself. Our oxasols are going to be our oldest soil. Oxasols, oldest. Anyone from Georgia? Anyone out from very East Tennessee? I've got those red clay soils. Have you seen them? Yep. There's nothing left. There's nothing left. They've undergone those weathering processes so much that everything's either leached out or been used up by the plants or whatever. Brazil, somewhere where the weathering process happens constantly. There's a lot, it's hot, isn't it? It rain a lot. So heat and water make that biochemical reaction happen probably maybe even 3 times as fast, because it's like 120 degrees over there, right? And then the humidity's there, so there's a lot of movement, and there are a lot of biodiverse microbial activity, animals that are getting after the nutrients that are in that soil. So it's depleted. Nothing else left there. Photosols, they have those aluminum and iron oxides. You're not likely to run into these. There may be some down in the panhandle of Florida, but you're not likely to encounter those. Next, we have Altisols, which are the second oldest. And so as we start getting more towards on this side of Knoxville, everything around the upper Cumberland region is pretty much an Altisol. I can't find many other soil orders. They've just been weathered enough. I mean, we get enough rain here in Cookeville, and it is kind of warm. So those processes are still happening. But we have a low base saturation because we get enough rainfall that water has moved those bases through the soil profile, or they either run off into the river. And then finally we have Bertisols, and these are our shrink swell soils in Mississippi. And if you've ever looked at Google Earth, I'll do some real poor drawing here. If you ever look at Google Earth, you can see this little crescent kind of right that cuts between Alabama and goes right up this corner of Mississippi. And so I went to college here. So just kind of over a little bit, we have these very dark, deep soils that they have a high clay content, and that water will get in there and it'll swell. And then when it dries, it'll shrink. And when it shrinks, it cracks. So then it rains a little bit, and now we get, you got this crack in this soil that maybe kind of starts out like that. It'll shrink and swell, shrink and swell, shrink and swell over the course of a growing season, and next year it'll be like this. The water gets in, makes this shrink and swell, this will start to crack, this will start to crack, and now you can't grow anything in there, because it's all cracked and it's just nasty, and it's dried out, and you can't grow anything. So you can't build anything on it either. So if you've ever noticed, maybe if you're driving on a road and all of a sudden there's a swell in it, or the asphalt has cracked, it's because the soil underneath it isn't stable. There's some clay in there that caused it to shift. You'll see buildings with cracks at the top of the ceiling, because that foundation has shifted underneath that concrete. All right, I think I've bored y'all enough with this stuff. It's gonna get better, I promise. It's just, this is part of the stuff that we have to go through. We'll knock this out on test 1, and then we'll move into the stuff that you're actually going to apply in your career. Okay? Y'all have a good weekend.